Okay, in this video we'll be looking at measures of central tendency, but the distributions or the samples that we'll be working with are given to us by different graphical methods. And so we're going to be looking at things like a histogram or a frequency polygon or a stem and leaf plot in order to get our data to calculate these measures of central tendency. And so we're going to be working with 4 different measures of central tendency. We'll be looking at the mean. Oops, very large pen there. Let's get our pen size down to more like what we're used to. We'll be working with the mean, which is x bar, right? We'll be looking at the mode, which is the most often occurring value. We'll be looking at the median, which is the central value. And then we'll also be looking at the mid-range, which is basically the average of the largest and smallest values in our data sets. Now, one thing to notice about this is being a histogram, it's not a binned frequency distribution, it's just a frequency distribution. So we don't have to deal with classes of data here. We just have to deal with data points, data values. And so we have 10, 20, 30, 40, and 50. For our data values. And so when I'm trying to do my mean here, what I'm going to look for, well, the mean is the sum, I equals 1 to n, so over all data points, of all of my data points divided by n, which is the number of data points, right? And so I can find my number of data points here by looking at the frequency side of my graph. And so I see this first bar has 5 data points in it. And so n equals 5 plus my second bar has 3 data points in it. So 5 plus 3 plus 2 plus, and then I have 2 bars at 1. And so 1 for the first bar, 1 for the second bar. Okay. And so how is that going to work out for us? We're going to do 5 plus 3 plus 2 plus 1 plus 1, and that's going to give us a total of 12. So n is going to equal 12. Now, that gives me the denominator of my calculation here. I still need my numerator now. I'm going to pull the whole teacher with a tablet thing, and I'm going to slide this up a little bit because I think we're going to be able to get away with that later. Now, the numerator is going to be the sum total of my data points. And for frequency distribution, it's going to be a little bit different than just adding together all the data points, because my data point value here is 10, but I have 5 of them. And so it's going to be 5 times my value. So I have 5 of these 10 valued data points. Okay, and that's the same thing as writing out 10 plus 10 plus 10 plus 10 plus 10. It's just, I think I got 5 in there. It's just written a little more compactly as multiplication. Okay, so now I'm going to have 3 times 20 because I have 3 data values valued at 20. And then I have 2 data values valued at 30, right? Because I have a 2 and the height of my 30 bar is 2. And then I have 1 data value at 40, and then 1 data value at 50. And that's all divided by, again, teacher with a tablet, 12. Okay, and so my x bar is going to equal, I'll put parentheses because it's going to be in the numerator, 5 times 10, or 50, plus 3 times 20, or 60, plus 2 times 30, another 60. So what are we at? 120 and 170. And then plus 40, plus 50. So it'll be 260 divided by 12. And just curious, 260 divided by 12. Did I do that right in my head? Hey, I did that right in my head. It's always good to keep a running tally and make sure you agree with yourself. Okay, so that's going to give me 21 2/3, or 21.6 repeating, Remember, 21.6 is not the same thing as 21.6 repeating, but this is a rounding. If we actually terminate that decimal by putting the bar over it, I'm saying that repeats for infinity. And so I'm actually going ahead and representing this number accurately by putting that bar over the top of it. Okay, now I never like to just turn my brain off and accept my answers that I generate blindly. I always like to think, okay, well, that 21.6, that's supposed to be a measure of centrality of this data set. It's supposed to be the average of my data set. And so if I put a tick mark here at 21 and I look at, the shorter bars over here and the larger bars over here, that actually looks like it's in about the middle of my data set as far as how much data is below and how much data is above that line. And so it's not a perfect check, but it does seem like this is a reasonable answer. And so I'll go ahead and underline it and say that's my answer. Okay. Now, the mode here, the mode is the most often occurring data value, right? So most often, or most frequently, if I use a better word, frequently occurring data value or item. Basically, that means the tallest bar. Well, the tallest bar is clearly this one at 5, and that means that 10 is my most often occurring data value. So the mode's relatively easy to calculate and doesn't take all that much space. The median, on the other hand, is the central data value. And to find a central data value, I have to organize my data in ascending or descending order. And this already is, right? Because we kind of have 10 up through 50. And so this is already organized in ascending or descending order. And the calculation is slightly different whether I have an even or odd number of data points. I already know I have 12 data points. I already know I have an even number of data points. If I have an even number of data points, there isn't an exact center, right? The center is going to fall between two data points. And so what I have to do is I have to find those two data points and then find the average of those two data points. Now, the way I find the location of that center is I use this formula of n plus 1 over 2. And that's going to give me the location or the number of this center. Well, n, we already calculated when we did the mean, was 12. And so I have 12 plus 1 divided by 2. I have 13 halves, or 6.5, right? Because 12 over 2 would be 6, and then 1 over 2 would be 0.5. And so what I have is 6.5 here. I think it's probably easier to see this when I think of it in terms of 6.5. And so I need the 6th and 7th data value. So the value below 6.5 and the value above 6.5, and I need to average them together. Well, the 6th data value, I go at 10, I start, and I have 1, 2, 3, 4, 5. Then at 20, I get the 6th data value is a 20, and the 7th data value is a 20. And so I want to average together this data value and this data value, right? Because my 6.5 would land me halfway between those two. Well, the average of a value in itself is just that value, right? We could do that math, but the average of a value in itself is just that value. So I know my median equals 20. If you want to see that math, what does it look like? It looks like 20 plus 20 divided by 2, because that's one value plus another value divided by the number of values. Well, that's 40 over 2, which is 20. Okay. Now, the mid-range, I'll go ahead and erase this so we can see what we're pointing at a little bit better. The mid-range is the average of the largest and smallest value. And so the way I like to write this is x min for the smallest value plus x max for the largest value divided by 2. Well, my smallest value is 10, my largest value is 50 divided by 2, And yeah, I'm going to have to do that whole teacher with a tablet trick again. And I'm also going to change the color here just so that we don't get confused as we're in and among some other calculations. Okay, and so that 10 plus 50 over 2 is going to be 60 over 2, which is 30. And so the mid-range of this data set is 30. And so I have 4 different measures of central tendency. I have my most frequently occurring data. I have the center of my data. I have the average of my data. And then I have kind of the center of my data values, right? My largest and smallest data values. So the center of my range of data values. And somewhere between seeing the center of my range of data values, the average of my data values, and the most often occurring data value there, we get a pretty good idea of where the center of our data set might exist. Okay, let's do this again. But let's use a different method, a different representation of our sample. This time we're going to be using a frequency polygon to see what our sample data is coming from. And so we're going to do the same calculations, right? We're going to need the mean. We're going to need the mode. Use as much space as I have here. The mode. Draw a line just to separate them. The mode. We'll have the median. And then we'll have the mid-range. Okay, the mean is just the average of the data, right? So the first thing I need to calculate the mean is the number of data points. Well, again, I have single values. I don't have classes here. And so I have 10 through 15 for my single values. And the height of this graph will have a 2 of my 10 values, right? And so that means I have 2 data points there, or 2 data values there. I have 2 of my 11s, and so there'll be 2 11s plus 3 12s plus 4 13s plus 1 14 plus 2 15s. And so my n is going to equal what? 2 plus 2 plus 3 plus 4 plus 1 plus 2. Gives me 14 data values. This is another even one, which means that my median is going to be a little bit more complicated, again, because I'm going to have to do the average of the central 2 values rather than just find the center value like you can in an odd number of data points sample. Okay, now to find my mean, I remember that x bar is the sum, I equals 1 to n, of all data points x sub I divided by the number of data points n. Okay, well, I have 2 10s, right? Because I have 2 10s. Similarly, I have 2 11s. Changing it up just a little bit, I have 3 12s, right? Because I have 3 12s. And I have 4 13s, 1 14, and then 2 15s. And then that's all going to be divided by 14. And so my x bar value here is going to be what? It's going to be 2 times 10 plus 2 times 11 plus 3 times 12 plus 4 times 13 plus 1 times 14. You don't really need to type that in, but I'm just doing it for clarity, just to show you where the steps come from, plus 2 times 15. Okay, and then that will all be divided by my n, which was 14. Hit enter, and I'll get a value of 12.43 if I round. So 12.43. And then remember, rather than just accepting the value blindly, I want to sketch in at somewhere around 12.4. I want to sketch in that X value and say, do I believe that about half of my data is below that and about half of my data is above that, which is what my average value should tell me. And yeah, that looks pretty reasonable. And so it's not a check of my work, but it's a, kind of gut check. Does this feel right? Does that seem right, or seem like it might be the right answer? And you'd be surprised how many times you'll end up doing something silly or typing something wrong in your calculator, and you'll get an answer that makes no sense whatsoever when you stop to think about it. Like say I'd gotten 15 out. Well, then I'd be trying to draw a line through here and say, wait a minute, that doesn't look like it's anywhere near the center of my data, and so I must be wrong. And then you go back and check and find your mistake. As humans, we're really good at making silly mistakes. And so one thing we have to do is figure out ways to avoid making those silly mistakes. Okay. The next one I'm going to look for is the mode, and that's the most frequently occurring value. And so since this is the frequency axis, what I'm going to want to do is I'm going to want to look at what's the largest value on that frequency axis. Well, it's 4. And so then I want to find out what data point had that largest value. Well, 13 had that largest value. And so my mode is 13, which occurs 4 times. I don't need to state that it occurs 4 times. I just need to know that the mode is 13. Now the median, remember I've got to have this sorted from low to high or high to low, and then I can get the position of my median using this formula. But being an even number of data points, this formula is going to drop me between 2 data points. I'm going to have to average those 2 data points. And so my mid-range is going to be at n plus 1 divided by 2. That'll be the position. And so it'll be 14 plus 1 over 2, or 15 halves, or a little bit more usefully, 7.5. Because 14 divided by 2 is 7, and 1 divided by 2 is 0.5. I'm adding those 2 together, so 7 plus 0.5 is 7.5. And so that's the position of, this is the position of the median. And so now I need to go find the 7th and the 8th data value. And so this tells me to find the 7th and 8th data values and average them. Okay, well, the 7th data value, how am I going to do that? Well, I'm going to go 1, 2, 3, 4, 5, 6, 7. And so my 7th data value is a 12. And then my 8th data value is a 13. And so I have my 12 plus 13 divided by 2, which is going to be 12.5, right? It'll be, 25 divided by 2. That's not a plus, that's an equals. I don't know why I wrote a plus there. It's an equals 25 divided by 2 equals 12.5. But it's going to be halfway between these 2 numbers, and those numbers being separated like an integer, well, that means there's going to be a half on one side and a half on the other, and 12.5 satisfies that. So you could have reasoned your way to it, but this is the actual calculation. Okay, now I need to find the mid-range. I'm going to pull that down here and change the color just so that we don't get confused by it being near so many other things. All right, so if I'm going to find this mid-range, this is the average. This is the average of the max and min values. And so, again, the way I like to write that is x min plus x max divided by 2. Well, in this case, that's going to be 10 plus 15 divided by 2. So it'll be 25 over 2, or 12.5. And so you can see for this data set, if I go ahead and erase my counting here, if I look at this data set's central tendency measures, I got a mid-range of 12.5. So if that's 12.5, that would be my mid-range. And then I got a median of 12.5 as well. And so my second measure of central tendency here, my median, is like literally right on top of that one. And then my x bar is 12.43, and so it's like literally right next to, closer than I can sketch, and it looked distinct. And so you can see that there's a very strong implication that my center is right there. And my mode is also quite close too, as a 13. Okay. Let's look at another way of receiving our data. So we have the stem and leaf plot. And we want to do the same calculations using a stem and leaf plot. Well, I'm going to do my mean first. If I do my mean first, that's my x bar. Well, to find that, I'm going to need my n, which is my number of data points. And basically, each leaf represents a data point. And so I have one leaf off the first stem, 4 leaves off the second, and 4 leaves off the third stem. Well, that's going to be 9, right? I can write that down, 1 plus 4 plus 4, but it better be 9. Yeah, n equals 9. Okay, now that I've found that, what I want to do is I want to sum, so I have that formula, x bar equals the sum at I equals 1 to n, so all of my xi's divided by n, my number of data points. Well, my number of data points is 9. That's easy. The deal is adding all of my data points together. Remember, a stem and leaf plot, you take one digit and make that your stem, and your leaves are the next digit of your number or of your data value. And so what I really have here is a data value of 28 plus a data value of 32 plus 34 plus 34 plus 39. Now we're moving on to that last stem. Now I've got 40 plus 41 plus 45 plus 47. And then that'll all be divided by 9. Okay. 28 plus 32 plus 34 plus 34 plus 39 plus 40 plus 41 plus 45 plus 47. Then we'll divide that by number of data points, which was 9. And I'm going to get 37.7. So that's going to equal 37.7 repeating. Okay. And if I look at this, now stem and leaf plots aren't always organized lowest to highest, but this one is sorted lowest to highest. And if I look at this, a 37 being in around here, that seems like a pretty reasonable measure of central tendency, right? It's about halfway through my data. Okay, now let's think about mode. So if I think about a mode, that's my most frequently occurring value. And if I look at all of my leaves, each one of them only appears once, except for 4 here, which appears twice on the same line. And so my mode is 34 because I get 34 here, and then I get 34 again here. And so I have 34 appearing twice, and that gives me my mode. Now I got to think about my median. My median's position will be n equals, well, we'll call it p equals n plus 1 over 2. And so it's the number of data points, 9 plus 1 divided by 2 equals 10 over 2, which is 5. And so I'm looking for the fifth data value. Now, again, stem and leaf plots are not necessarily sorted, but this one is sorted. And so I'm going to count to my fifth data point through the sorted frequency distribution. And so I have a first data point, I have a second, a third, a fourth, and a fifth data point. And so my fifth data point, based on that calculation, is my central data point. And you can also kind of see this because I have 4 data points before it and 4 data points after it. Okay, well that mode now, that median is going to be 39 because it's the stem is the tens place and the leaf is the ones place. All right, last calculation here. Let's look at the mid-range. So if I'm thinking mid-range, that's going to be the highest value plus the lowest value. So x min plus x max divided by 2. And so that's going to be 28 plus 47 divided by 2. 28 plus 47 divided by 2, and we get 37.5. All right. I think that's probably a good set of examples. I had 2 more histograms we could look at, but they are a little bit repetitive because they're also both histograms. So I think we're going to stop there on calculating these measures of central tendency. I hope that helps us out.